Good morning, and thank you very much for coming to this session about JSON processing. That's going to be implemented, this new feature for Java E8, and it's something that it's coming. And probably all of you are here because you know that JSON format is becoming the de facto format for REST API services. So probably you want to know how you can, parse JSON files in Java. My name is Alex Soto. I'm a software engineer at CloudBees, but also you can find me in several open source communities. I'm also the author of Apache Tomcat RefCard, and currently I'm co-working with Jason Porter in the book Archillian in Action.
Okay, and my name is Mitreski. I work for a software company called Klarna in Sweden. I'm also involved into various open source communities. And the two of us have been involved into the expert group for adding new updates to the JSON Processing API. Okay, so for those of you who don't know what the current JSON Processing API is, that's JSR 353. Basically, it's the JavaX.json packages. So, I mean, it has a little bit unfortunate naming because it's called JSON-P. So this is not padded JSON. It's not JSON-P as padded JSON. It means JSON processing. There are several classes that were already part of the API. This is like a low-level API for trivocal building of a JSON. So JSON reader, JSON writer, JSON values, and so on. There are currently, for this API implementations, the reference implementation is in Glassfish. There's also Johnson, Geneson, and so on. You can include the dependency like this on non-Glassfish servers, but this is provided in some versions of Glassfish. So we were not going to be talking about the current API. We're going to be talking about the additions that we've been working on as part of the expert group. So those additions are basically mostly IFT standards. So I don't know, RFC 7159. Also called as the new JSON. We'll be talking about the additions that we have put into the JSON objects for transformations and for creation, and certain facilities that enable some of the other work that we have done. Also, we'll be talking about JSON Pointer, JSON Patch, JSON Merge Patch, JSON queries, and some alignments that we have been doing with some of the other teams working on other aspects of Java E. Okay, so JSON. What's JSON? It's one of the things that became really extremely popular. The specification was written initially by Douglas Crockford while he was working at Yahoo at the time, I believe. So it's something that was written in 2006. It's also RFC standard. And, I mean, it has proven to be extremely successful. There are hundreds or if not thousands of implementations in almost any language out there. It's one of the things that's kind of the de facto default format for using nowadays. Okay, so what has been changed in the new standard? Okay, the new standard is something done by a guy called Tim Bray from Google. If you actually read the RFC document, there isn't really much change there. It's mostly like fine refinement of certain implementation aspects. So when people were implementing the JSON parsers, they would make certain mistakes and certain assumptions, and that would cause incompatibilities between different JSON implementations. The incompatibilities usually are really minor, like, I don't know, someone used true uppercase and lowercase, the case would not matter on a value, but in other implementations that might matter. But what's really a big change in this standard is that you can actually add values as a top-level element in the JSON object. And that's the actual big change. So beside that change, we also are working also on the reference implementation. We are doing that in order to actually get better understanding of how the actual API will work. So there are a couple of things that we added. These are these these are these factories for creation of the immutable objects, like create value of something, of string, of integer, of big decimal, and some of the common objects. And we added some stuff in the interfaces. Because we have the ability to use Java 8, this makes it a lot easier to be backwards compatible. So we were able to add this read value and this write value to JSON reader and JSON writer, and keep the API backwards compatible with the current implementations. So just by switching the API to the new version, it will not break the current implementations that are already in the serverless containers. So few of other additions that we've been doing are related to JSON array and JSON object transformations. So for example, like we have added certain elements that make it a lot easier to kind of build programmatically a JSON object. These facilities enable us to easily implement the other parts that we'll be talking on later, but they're also really nice goodies that are actually kind of builders for the standard JSON objects and JSON arrays. So they add like various of editing operations, and we'll have shortly a look on them. For example, one of those is this JSON array transformations. So if we have this array builder, so this is a builder, we add various elements. We can set, remove, and so on, do various operations on top of this builder, and then at the end have a built object, which can be JSON array or a JSON object, and so on. So for the builder, for example, we set add this value, and so on. It makes the work a lot easier on creating programmatically a JSON object without having to actually create a Java object that kind of maps directly to the JSON object. And there are quite a few use cases for that. And we head over for JSON Pointer.
Yeah, in JSON-P 1.0, we had, where we implemented the ground of JSON processing, like, reading and parsing JSON files or writing files, and, have this map-like thing to get and put elements inside a JSON object. But now for JSON-P 1.1, we decided that we are going to implement some JSON RFCs that are public, and one of these is JSON Pointer. JSON Pointer is, it's a syntax for identifying a specific value. It's not a query language. It's like put a pointer in, in a part of your document. This part can be a JSON single value, or it could be a JSON object. And the syntax, it's pretty, easy. It's, you do a slash, then you put the first element, a slash, the second element, and so on. Very easy. If it's an array, you do, that the name of the array, slash, and then the position, 0, 1, it's 0 based. Of course, since in JSON Pointer you're using a slash, if you want to, a slash is still a valid character for a JSON name. So if you want to use it, you need to use this, this strange, this tiled 1. Of course, if you are using tile 1 and you want to do tile 1, you need to, add the tile 0. So it's quite, if you use these special things, it's quite, your JSON Pointer expression is harder to read, but yeah, you can do it. And also one thing that is really important is that a JSON pointer is an absolute path. You cannot refer to, to a relative position like ... slash blah, blah, blah. And if you do it, JSON Processing API will throw you an exception. And yeah, this is an example of the OpenBeers database, which first thing, you are reading a JSON structure. JSON structure is, the common object between your JSON object and JSON array. So it's anything that is in JSON. Then you create a JSON pointer, which is the brewery / key. And if you want to get the key value, you only need to call the P, which is the JSON pointer dot get value. You pass the JSON structure, and it will return, in this case, Guinness. So as you can see, JSON pointer is just a direct point to the brewery key element. But this is what RFC defines, but we decided that we could even add more operations for you, because it's like, okay, I have the pointer, but maybe I want to do something with this pointer, and we added these 3 operations: add, replace, and remove, which adds something in that position, replace something of this position, or remove what you're setting in the JSON pointer expression. And yeah, this is an example. The same. We read the beer, we get the key, and then what we want to change is from Guinness to Guinness Brewery. So you do a P, which is the pointer, replace, you pass the JSON object, and you pass the value that you want to replace. And when you do the p.replace, it returns a new JSON object with the change. Let me show you in action. This is, wait, I can show you also the file. Okay, this is the full document, which, as you can see, it's the key Guinness, title, synonyms, and so on, all the information. And now I can change here the class, which, wait. In this case, what I'm getting is the country and the title of the country of this beer. You get the value of beer, and we print it on the console. Then we also get the first tag of the beer. We get the value, we print it, and also here we are replacing the country title to IR. And notice that here I'm printing the beer and the new beer, and this is because you will notice that JSON objects are immutable, like the strings. So you can do a replace, but you are not changing the original document. So here it runs, and as you can see, the country name is Ireland, which is the first expression. Then the first tag is it is really, well, this tag, and then you see that the all beer info and the new beer info, which is when I did that replace of the country name. And if you go to the expression, you will see that country here. The first one is Ireland, and the second one is IR. So both documents are different, since both of them are immutable. But yeah, this is one thing that we implemented, the JSON Patch, and JSON Pointer. But now we also implemented JSON Patch, which is our RFC 6902. And I will ask you, how many of you are implementing your job REST API services? And all of you who are using JSON? Yes, in the REST. Okay, so probably you are using, you are implementing CRUD operations, and you use post for create something, get for querying something, delete for deleting the object. But how you implement the update of a document? Probably most of you say, yeah, I've read that it's put. But put is a create or update. So you need, if you want to be compliant with the REST spec, you need to implement both operations. And this is one thing that you need to take into account. And the second one is that how you implement the update. You need to start thinking about the format you're going to use. Maybe you decide, yeah, if I send a field with null, it means that I want to delete this field, but what's happened if my field also is nullable? Or, well, maybe I send only the changes that I want to apply, or maybe you create your own format to set to your service that you want to update some fields, which is okay, but if you don't know, there is an RFC that says how you can update your JSON objects, and this is JSON Patch. Basically, as I said, it takes a standard way for update operation in the JSON app and JSON document, so it's for your REST services. And basically, it defines a sequence of modifications to apply to a given document, which are these 6, which is test, which is like an if. It tests if a document is equal to the value you are providing. You can remove, you can add, you can replace, you can move, or you can copy. And the key point on all this sequence of modifications is that they are transaction. I mean that they are applied all of them or none of them. You're not going to get some inconsistencies with the generated JSON object. Also, JSON Patch is a document which is a JSON document, so we are not using another format rather than JSON. And it's quite important to notice that it's also an HTTP method, which is HTTP patch, which is application JSON patch JSON. This is the media type that you need to use if you want to use patch. So you can still use put if you want, but yeah, patch is also correct. And this is an example of a patch where you notice that this is an array because it's a sequence of operations. The first element is op, which is the operation you want to apply, which in this case is a replace. Then path. Path is a JSON pointer to the element you want to replace, and then the value you want to, or the new value you want to put in that path. And again, with the remove, you need to add the JSON pointer of the element you want to remove. And in this example, you see that this title, Guinness Brewery, the key is Guinness, and I'm replacing the key to Guinness Brewery, we just change it, of course, and I'm removing the title, and the title, yeah, it's removed. And how to do this with JSON-P? Well, there are several ways to do it. As we have said, JSON Patch is a JSON document, so you can create an array builder, you create your object builder with the op, replace the path and the value and so on. Then you create a new JSON Patch object where you put the JSON array. And then I read the JSON structure, which is the beer, and I do a JSON patch.apply to that document, and I will get the result document with all the changes applied. This is one way, which is, it's okay, but you need to remember all the op path value and the valid values for op, for example. So we implemented the JSON Patch Builder, as in all the JSON-P spec, and you can do something like this. You can create a patch builder and say dot replace this JSON pointer with this value, dot remove, and finally dot apply, and you put here the element, and you get the result. So you don't need actually remember which is the format of a JSON patch. But as it happens with JSON Pointer, we decided to add extra operations that are not defined in the RFC, which is taking two documents, get which is the patch I should apply to go from A to B. It's like like the reverse operation we have seen, and this is really useful in case of conflicts. If you are using, for example, Hibernate, and when you try to change two objects at the same time with optimistic locking, you will receive something like concurrent modification exception or this kind of exceptions, which means that there is a conflict with the two versions you're trying to save in the database. And this also can happen with JSON objects. So if you want to provide some feedback to the user, instead of saying, there is a conflict, sorry, we cannot do anything with you, you can say, there is a conflict, these two objects are there, and if you want to go from A to B, you can apply these changes. And it's, directly provided to the user. So in this case, what you do is calling this static method with JSON-Patch.diff. You put the two objects, in this case the two beers, and it will get as a response which JSON patch operations you should apply from beer 1 to beer 2. Let me show you JSON Patch demo, which is quite similar of the JSON pointer of what we have seen now. We are reading again the same document, which is this one, which is the Guinness beer. And basically, here I'm building using JSON Patch Builder the replace of the country. I test that the country key is IE. If the country key is not IE, everything will be abort. I'm removing the first tag and I am applying the patch to that object. Also here is an example of create array builder. It's exactly the same as before, but creating myself the array instead of using the builder. And finally, here you can see a div of both beers. So I'm going to run this. Notice that it's fast to apply all these changes. And see that in this case, the patch builder, it's replacing the first tag. Notice that, wait, sorry. Originally, it has 3 tags, 1, 2, and 3, and now it's only 2. And also the country has changed to IR, so it worked. Also, it's the same for patch array, and here you can see the div. That from beer 1 and beer 2, the only change was the country title. It says that, okay, if you apply this patch to object A, you will get the object B. And
okay.
You can, yeah.
So, okay, so JSON Patch was one of the IFT standards that we implemented. So it kind of adds a little bit complexity to your app operations because you need to know about all of these operations like remove, replace, and so on. What I really like is another standard that we added to the reference implementation as well as to the spec. It's something called JSON Merge Patch. So it kind of does the same functionality. So its idea is to standardize the update operation, but it has one limitation. The idea is that we kind of mimic the change we want to do in the object. So when we do an update, we would need to actually put just the change that we want to do. Realistically, if we are like purist REST API, when you do a HTTP put, you put the entire object, like together with the changes. But when you were supposed to do an HTTP patch, you're gonna send only the update that you want to do, just the partial change of the object. The way to delete some element is to set the value of null to that element. So this is the actual limitation of this mechanism. You cannot set an element to a value of null. If you set an element value to a null, that element will be deleted. So that's the only limitation that this mechanism has. So it also has like a different media type, and its intention is to be used with HTTP patch. So the media type is application JSON patch plus JSON. So how would that look in practice? If we have this JSON document with the beer, title Guinness, we want to delete the title. When we do the put, we just say title equals null. And that deletes that object. If we want to change the title, we can say title equals something else. Obviously, we cannot set the value of title equals null. That's the only limitation. But it's really a pure mechanism. And if we take into account in our head, if we wrap around our head that this is the limitation, then it's totally fine because it's really, really simple mechanism to understand. So how does this look in the API? We have this JSON structure beer, and we say remove title. So we create an object that will do the operation itself. So title equals null. And then we say merge patch to the beer object. So we say to the beer object, you're going to remove the title. That's the actual operation that we're going to do. Keep in mind that this is intended to be like a low-level API. Technically, when you would be using this in some other mechanism, if you don't need to do low-level operation, this should be in theory done automatically. We also added a diff operation, as we did for the previous implementation. So to create a diff between two documents. And this diff is actually, at least to me, it looks a lot nicer because it's kind of like actual diff between the two documents, like git diff more or less. It's also quite useful in case where we have conflicts when we're trying to delete elements that don't exist and so on. So, yeah, if we diff the two documents before and after the update operation, it will give us this title null. It will give us the actual diff between those two changes. And it's quite useful, actually, if you try to do some kind of testing of JSON APIs. You can do like diff between two different elements, and you can use it for other purposes as well. And it's Alex time.
Can run the demo. It's exactly the same we have seen, but using Merge Patch. Also, we have some discussions in the community if we should provide both implementations or not. And it's if we choose one, probably there will be other people will say, yeah, but I want to use the other one, and on the other side. So we decided to implement both, and you can choose which fits better for your business or whatever you feel more comfortable. And yeah, in this case, it's exactly the same, but with using Merge Patch, and we're having the beer, and we want to remove the brewery in this case. So I can run the demo. And again, you can see that in this case, the brewery is null. Let me notice that there is no brewery element here because it's been removed. And yeah, if you do in this case, two elements, which I have this. In this case, I'm using the diff with this element, which in fact, in this element, what I've done is changing this value and the title here. So when I run the merge, the diff, it returns the document that I should send to Merge Patch to get from A to B again. And notice that now, instead of being a JSON Patch structure, it's a JSON document very similar as the original one. But, Java E8 is going to be released under Java 8, as a requirement as a Java 8 as minimum requirement. So we decided also to update these changes to the JSON API. And we created something that's called JSON queries, which basically is an implementation of the streams. So as maybe you may know, but in JSON Processing API 1.0 and also in 1.1, a JSON object is a map. And a JSON array is a list. So we have almost all the operations there for writing queries, since both map and list provides streams. And I said, yeah, we are almost there, but we need to do some things. We're like basically implementing collectors to do some magic with the streams. And I think it's quite interesting because with the streams you get, concurrent processing for free. So you are able to run queries into a big JSON objects in parallel, and without implementing anything new. Basically, the change that we have done is create a JSON collector with the toJSON array, which puts all the values into a JSON array, toJSON object, which is the same as for JSON objects, and the group by operation, which is quite different. That was how it's working with map. Let me show you some examples because, they're quite big and also interesting. Now we've changed the example to this one. This is the one that is provided in the spec, which is a name, it's people, or Duke, Jane, and Joanna. This is the gender, the fonts, this, typical example.
One thing, Alex, to interrupt you. One thing to note, if you're noticing, because in Java, double quotes.
Yeah, the quotes.
Yeah. So the quotes, this is like a utility method that we added. So basically, we are using single quotes, even though single quotes are not really JSON allowed. But this is like to have a nice view in the Java code that you're developing. This will be replaced, the single quotes will be replaced with double quotes, and yeah, it's just a utility method. And
well, the first one is what I have the first one, all this element, and I want to get all the all the elements that are the gender is an F, and I want to get all the names of of the JSON object. So of this object, in this case, there are Jane and Joanna. So basically, I do the streaming, which is .filter, blah, 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 .map. And then the collect, notice that we are using the JSON collectors instead of the collections collector or whatever. And we are transforming all these elements to a JSON array. Then also we can do things more advanced, like instead of creating a JSON array, creating JSON objects. So you can take all your JSON object, process it in some way, and generate another JSON object with the elements you feel or you think that are interesting. In this case, what you're doing is take all the elements that has a gender F, and then build a new JSON object with only the fields name and the fonts, and in the fonts only the mobile. You can do it this as well. You can create your own JSON document. Also, you can use group by, so you can get a JSON object wrapped by the gender field. And finally, and this is quite interesting, you can even create a JSON Patch element querying. I mean that in this case, what we are doing is I want to replace the age with age plus 1 in that document. So what I'm doing is pick, which means don't do anything but what you want to do with this element. And in this case, I do index plus plus because it's initialized to -1. Then I'm getting all the JSON objects that has an element age, because there are some documents that don't have the age. And finally, the builder, that notice that this builder is a JSON Patch builder. I'm calling P, which is the element, replace the index, which is, since it's an array, it's the 0, 1, 2, and so on, the age field to age plus 1. So effectively what I'm doing is, in this document, getting Duke, now it's 19, Jane is 24. This is what I'm doing with this expression. And of course, finally, since it's a JSON Patch builder, I can do builder.build, and I get the JSON array. So let me run all this example. This is the original file with, you have already seen. Test to JSON array is Jane and Joanna, as we said, because it's all the female genders in these JSON objects. The second one is, remember that we said that what I want to do is return a JSON object with the name and the mobile. So I get a JSON object with the name and the mobile. The group by thing, which is female, there are 2 objects, JSON objects with female, and with male only 1. And the patch, notice that we have created this patch object, which, as I said, we are replacing the 0 and the 1 element to be 19 and 24. And of course, the result is that Duke and Jane has plus 1 age, but Joan has the original element. And another thing that we add is that you have probably noticed that we are talking about JSON objects in JSON array, and I said that this is, in fact, internally a map or a list. So if you have a really big JSON object, you will need more and more memory. And since JSON objects are immutable, if you make one change, you will have the double of the memory, and so on. It's like the string problem. And this is, and we face it that when we think about big JSON data, it's like, log files. Not, you can have a more or less big document for your business, which is okay to do it with JSON objects or JSON array. But if you want to process log arrays, then maybe you will have some memory problems. So also there is too big to build data model in memory, as I've said, but also that what's happening if you are creating or generating JSONs dynamically. It's in a stream and you are sending and sending and sending JSONs, documents like, for example, in a log way. And if you need all the document, you will need to load all the document, of course, but what's happening is of all this big document, you're only interested in some small parts of the document because the rest doesn't affect your business, for example. So what we have improved is the JSON parser class. JSON parser class is a class for parsing that JSON object, but it's using the streaming model that we have seen, for example, in anything that is in JAX-RS, or, for example, it has something similar. It's a streaming model. And it's a pool model where you get all that you need it. And since you are only getting the information that you need, it's an efficient way of getting information, and it's very, very low memory requirements. Basically, you have two methods, a skip array and a skip object. So you start with your streaming and you say, okay, I want to skip this object because I know that I'm not interested, so you call skip object, and if it's an array, you call a skip array until you arrive to the object that you need, and then you can read it. And at that time, you only get into memory the part that you need. Let me show you here. We have an example. In this case, we are using, it's quite, let's say, it's a bit funny because we are using GitHub Rail issues, which is quite big document because we go again to GitHub and we download all the issues and we put it into a file. So as you can see, it's big. We could probably in this concrete example, you will not get out of memory errors if you put like 1 GB of RAM or 4 GB of RAM, but it's not the way to work. So in this case, I'm reading the issues, and the first thing that I do is if it's a star array, because it's an array of issues, I get the object. I read the object. I see if the state is open, and I limit to 5, and for each of these elements that are open, I print the element, and finally I skip the array. So in this case, the only elements that I'm going to load into memory are those that the state is open, and the rest of them will not be on memory at all. So I can run it, and you will see that it runs really fast with a big JSON document. And here you can see all the issues that are open. Quite fast and low memory usage. So now, I think that we're going to talk. Any question about what we have talked now? Because now we're going to talk about the alignment with another specs.
Yes. So the question was, what happens if I want to set a value of null to some? Yeah. So with the JSON Merge Patch mechanism, you cannot do that. But with the mechanism we're using, operation and pointer, you can do anything. But there it's more explicit, more explicit API. But with the JSON patch, you cannot do that. You cannot set the null. So it's kind of opinionated. It says that's the only thing you cannot do. But Yeah, I mean, when you think about it, it's kind of a valid architectural decision to make for the benefit of simple usage of patch operations.
Why don't you just implement the operator like unset?
Well, because this is the RFC.
This is like
I mean that this is, what I mean is that maybe this will be another discussion in the sense, but it's something that RFC says that JSON Patch works in this way and JSON Merge Patch works this. So yeah, in fact you can with Patch you can do JSON value.null, which is a static field, and you have the null there. I mean it's quite easy to do it. But we'll have questions at the end, so we can, if you notice something, feel free to say. Then let's say JSON-B. JSON-B is a new Java E8 specification, which it's used for Marshall and Marshall Java objects to or from JSON. Yeah, probably most of you are still using JAX-RS or JSON or something, or JSON, for example, for doing. But each one, it's not, has not a common ground for work. Each of these implementations does the things how they want. So if you want to use JAX-RS, you need to learn JAX-RS. If you want to use JSON, you need to use JSON. And JSON, you need to learn JSON, and so on. So in this case, what JSON-B provides is a common interfaces for the implementators. It's not a new implementation. JSON-B is not a competitor of JAX-RS or JSON or JSON, but it's a common interfaces that all of them would adapt. It's like JPA and Hibernate or an Eclipse Link. I mean that you have JPA and then the implementators implement those interfaces. But JPA is not a competitor of Hibernate, for example. And JSON-B, all the integration with JSON object is that it must provide some binding for the JSON Processing API. So it means that when you try to bind something, you can put a JSON object as well as an attribute. And this is quite useful in the cases of you have dynamic elements and some static elements, because you will be able to create an object with some fields that are common to all elements, and then for the things that are extra that some objects may have and some not, you can create a JSON object there. So you will have your static part being with getter and setters, as you usually do with JAX-RS or JSON or whatever, but also you will be able to have an extra elements that are not common in all the objects. And well, if you are interested in how to create or how it's going to work with JSON-B, we will create a JSON-B builder, and then you can, from JSON, you put the JSON and you get the book in this case, or you can write the book to a JSON file. Yeah.
Okay, so these two patch mechanisms that we mentioned are the only part of the additions that we added that don't make huge sense without having them integrated in some kind of web application. Because both of those are intended to be used with HTTP patch. So we are trying to make some alignment with JAX-RS implementers and the specification leads to have this as part of JAX-RS. So when you have like a patch operation, if you consume the appropriate media type, then you can do the appropriate media operation, depending on that. This is one of the options to have like update book where we have like JSON patch, and that will allow you to map to the JSON patch object. But there is also an option to make this automatically. But this is still a work in progress, so it's far from finite. So while we are on the aspect of work in progress, even though we said that this is already all implemented, this is far from final. So the roadmap, you can see the early draft of the specification on that URL. The roadmap is for Q1 of 2016 to have like a public review, and like Q2 of 2016 to have the final draft of the specification, and to actually have the release somewhere in 2017.
Yeah.
So this means like come to us, come on the mailing list. Yeah. to links to mailing lists and tell us like you're idiots, you're doing something wrong. You suggest like some improvements. Maybe you think some of these things shouldn't land in the API. We would like to hear about it. So there is a public project on JavaNet. There is also the mailing list that you can subscribe, and there is like Jira for issue tracker, and you can play around with it. So this is all part of the Java community process.
If you have any feature that say, it would be great that we will have this feature also in the JSON Processing API, please, use Jira or mailing list, or you can send me an email directly if you want, if you prefer to, be not so public in this way. And we can discuss and we can implement, because we are not close to implementing new things. That it's for all these features are implemented, are tested, are ready to be used, but it's not close. So if you have anything, please, you can touch us for sure.
As I said, there is, for the old API, the site is still JSON-P JavaNet without the with the new additions. But when we were planning to actually update the site eventually. We don't want to do that just yet because a lot of things are still floating. They're not final. You can check out the repository. It's available on JavaNet. That's the actual official repository. So if you want to do some patches or submit patches or submit some kind of updates, you would also need to be part to go into the Java community process. But additionally, you can do that, and you should use that repository. But we were kind of pushing to have this code also on GitHub. So we have like an unofficial mirror on GitHub that's auto-updated on GitHub. So whenever something changes in the original repository, it's auto-visible on GitHub as well. Yeah, so there is the Jira for the issue tracker of JSON-P. And yeah, by the way, this super cute girl is his baby girl. So
yeah. Well, as I said, if the questions also, here is the tweet. So you can tweet us with any suggestion or any question. But you have now any question? Yep.
What happens with pointer if it points to something that doesn't exist?
It throws an exception. Yeah, it does. It's not. That doesn't return a null. It returns that. Yeah, probably this is. Yeah, sometimes it's like it should return an exception or not. But since it's a pointer, it's a static information. Since JSON pointer is also immutable. Yeah, it means that if it's a bug in your system, that in your expression, so it returns an exception, yeah.
But it's not a null pointer, it's actually an exception from the JSON defined library, so.
Yep.
You showed us that you can test for a condition and then do operations. Can you test again after those operations?
I think it's quite interesting. I don't know their RFC would.
Alex, can you repeat the question? Just.
Oh yeah, sorry. They say that if you can test, then apply some changes, and then test again, right?
Right.
I don't know what the RFC say. I would need to check because I'm thinking about the algorithm that suggests, and this kind of thing. I don't know. I need to check in the RFC because this exact thing that I never. Yeah. And now, it's probably, that when you implement it and you follow the RFC, you see and you follow, because in these cases, the RFC provides a pseudocode implementation, so it's quite easy. But now I don't see, I think that it would not work, because it has not much sense to test something, modify something, and test that you have modified something, because since a JSON patch is inside a transaction, not a database transaction, of course, but it seems that if you have done a change, the change is there, because if not, it will throw an exception. So I don't know, and in this case, exactly which happened, but yeah, we can try it now in a moment. Yeah. Yeah?
Yeah, there was.
Yeah?
Does JSON Pointer support some wildcards?
Well, no, there's no. The only it asked if they support some kind of wildcard for the JSON pointer expression. No, JSON pointer only supports the characters that are supported in a JSON object, plus the, the same characters. The only thing that it's a bit strange is with arrays that you need to put the /0, /1, and so on. But the other thing, it should be an absolute path from a concrete object or a specific value.
But also, I mean, if you think about it, they doesn't make much use cases for having wildcards. I mean, it's not like for XML there was XPath. There it made much more sense to do that kind of operation. Here it's just to actually point to something more explicitly, kind of.
Yeah, because the, JSON pointer is not for queries. It's for pointing to an exact point to a document. Yep.
Is there a method to test if a pointer exists?
Method test? No, in this case it will through a tester is for testing if this the element you are pointing has this element, this concrete element. Doesn't test if the element exists or not. So if it not exists, it will throw an exception.
But it might be something that would be like a useful addition. I mean,
the problem is
consider that it's it's still ongoing, but that would be some interesting suggestion to discuss.
Yeah, the problem is that we are also linked with RFC. So
It's a step into the direction of going into query.
to queries, you mean like you mean there are some projects. You mean like XML, XPath, and so on, right? There are some projects that do that, and this is something that we have not discussed yet. But maybe it's a good thing that we can discuss. And it's a good point, I think.
Yeah, it's
I mean this is exactly the purpose also of this talk. It's getting the feedback and discuss. Yeah.
Any other questions? Yeah.
Is there any commitment from the JAXON and JSON and other projects that they intend to support this?
Yeah, you need, in this case, JSON-B.
Yeah.
I don't know. I mean, for as far as I know, there is no commitment.
There was like a question today on mailing list about the implementation for JAXON specifically, and they basically said this raises in popularity, we will definitely implement it. But if we see that there is no market for this, we're not going to implement it, which is kind of the other way around, because it's usually that we take something from the libraries and we put them into Java EE. It's not the other way around, but that's what at least they said. And for JSON, there isn't anything. JSON and Jettison, I think those two said they will do some kind of commitment, and one of them leads of those projects is part of the expert group. But
also, I think that it will have sense because, for example, JAXON only offers you JSON Pointer, but not JSON Patch or JSON Merge Patch. So I think that it's something that it allows grow them as a community, being a part of the Java EE spec. But it's something that we, as far as I know, I think that they should because, for example, the JSON Patch, JSON Merge Patch are implemented in the core of the spec. So it means that you can adopt any JSON-P writing implementation of JSON-P, and you don't need to think about how you are going to implement JSON Patch or JSON Merge Patch because it's provided by default for you. So if JAXON or JSON adopts JSON-B, will adopt JSON-P, and they will have out of the box JSON Patch and JSON Merge Patch. So I think it will be interesting for them to use it.
One other thing that we didn't mention actually is there were some ongoing talks about having JSON API in the standard edition of Java. That JAP was dropped officially until we have value types. So that's what the official response was there. Until we have value types, we are not gonna add anything into the JDK. So there was discussion of whether or not we should ever have this in the first place, because if there is something in the JDK, then some of this functionality, at least the low-level operations, would maybe not make sense. But this will probably not happen until Java 10 plus. Okay.
Well, okay, as I said, we have our Twitter. If you have any question, feel free to ping us.
Yep.
Thank you very much.